Hello, I'm glad you made it through the introduction lecture and now you're here on the second video, which is the elimination rate constant. So let's just get right into it. Elimination rate constant is a first order process and it depends upon the amount of concentration of drug. Like we can say the amount of drug that we are taking is going to be eliminated. Like over here we're considering one compartment, so amount of drug that we're putting in it is going to be the amount that we're taking out of it. Is going to be the same rate of elimination. So if I simplify it more, it's like if you have a bottle of Coke of 1.5 liter, you have 1.5 liter in the bottle, so obviously 1.5 liter is going to come out of the bottle. It's going to be the same amount. So in the same way, in the body, if you put like 10 mg of drug in it, 10 mg is going to come out in this case, in the case of one compartment IV bolus administration, right? And let's get to the units. The units that elimination constant has, it's time, right? It's going to be measured in time. Now over here, it states that the elimination is affected by the metabolism. So what we do, we give it an equation of the elimination rate constant, and we say that the elimination rate constant is equal to the metabolism and the excretion. Obviously, the time it's taking to get out and the time it's taking to metabolize, right? We can term that as the elimination rate constant. I'll simplify it ahead. Yeah, so what I gave an example before of a glass, like we have a glass of water. So over here, I'm going to state that again. We have a glass of water, right? And if you put a disperine dispersible tablet in it, the disperine, it will spread everywhere. It's going to be distributed evenly throughout, and it's going to take like 10 seconds or 30 seconds. It's going to take a specific amount of time to distribute. And after, when that's all dissolved, obviously you're going to drink the disperine, right? If you want to get better, and if you're not a chick, you're going to just drink the disperine and it's going to be eliminated, right, from the glass. Like if you imagine that as a compartment, you have the drug in it and then you're going to take it out, so it's going to be eliminated. So in the same way, what we can say that elimination rate constant is going to be equal to, like it was disperine, so it's going to be the amount of drug, and the time that it took to distribute is going to be that time, right? So we can say that dB divided by dt is equal to minus k dB, right? So dB is the amount of drug, dt is the time, and k dB is the elimination rate constant is k, so it's the amount of drug that is getting out of there. I hope you got it. I never got it in my student life. So, and okay, now next what we have is equation is a first order reaction rate law. Now what we have in this is a specified equation, right? We have in here is A is equal to A naught E minus KT. So A over here, it represents the initial concentration. Now what we have over here is we have the drug, right? So the drug was termed as dB. Now over here, what we're going to do is we're going to replace A by dB. So what we have is dB is equal to dB naught E minus KT, right? That's the final equation that we have over here. It's just like one basic rate law, and we've just inserted what we have over here. We have the drug concentration. That's how we got the final equation over here. Now, if you want to get rid of E, right, you take a log of it, and E has a value of 2.3, right? So if we're going to take a log of it, we're going to rearrange it a bit so you don't get too confused. So what we have is log dB is equal to minus KT divided by 2.3. So E has a value of 2.3, and it's going to be plus log dB naught. Now dB naught is the drug at time 0. I hope you seriously got it, because I don't know what I did there. Not really. So what we're going to have a straight line if we plot it, and the slope is going to be k divided by 2.3. I hope you get to learn that in graphs. Otherwise, I'll explain it. So that's all we have of elimination rate constant. So we know the unit is time, and it depends on the amount of drug that we have inside is going to be eliminated. And then we just have a simple rate law, right? We just have one equation and we just replaced it with dB, and then we took a log of it. That's all it is. It's actually really simple if you get a hang of it. Anyway, thank you for sticking along, and the next video lecture we'll have will be on apparent volume of distribution.